Alright, so I'm going to start off this section 2.2 video with a quick review of section 2.1. And there are basically, two kinds of problems in section 2.1 that will make it onto the test. And without the instructions, the problems might look the same. It's going to be you need to have the ability to differentiate what to do on a problem based on how it's set up. So this is the first style of problem. It's not in the handout or anything. I'm just making it up right now. I could have the instructions that say find the domain, and then I may have words after this saying write your answer in words or write your answer in interval notation. But somehow the word domain is the keyword in the instructions that's going to tell me what to do. So let me just make a problem up here real quick. I'll do lots of plus signs to make it somewhat easy. So it would be nice if you could pause the video and work this problem out and get to the correct answer. And I'll do it right here. So in order to find the domain of any fraction, the first thing I'm going to know is that I'm not going to do anything with the numerator. So I'm going to ignore the 3x squared plus 13x plus 4, which is the numerator. And I'm going to solve the denominator equal to 0. And because the denominator has a square, when I'm solving the denominator equal to 0, I'm going to factor and then set the factors equal to 0. And then I write my answer. So this is reasonably easy factoring. I don't need to use bottoms up. There's no minus signs, so I don't have any minus signs in my parentheses. The numbers that I put after the plus signs have to multiply to 8 and add to 6, and that's going to be a 2 and a 4 or a 4 and a 2. It doesn't matter if you put a 2 in the first parentheses or a 4 in the first parentheses. Once you have the problem factored and set equal to 0, after I note to forget about the numerator, you split the factors up and set each one of those separately equal to 0. And this gives me not the answer, but the numbers to exclude from the domain. Because I didn't indicate how I want my answer written, I'm just going to write my answer in words. And I'm not going to write my answer in interval notation, but if you wrote interval notation, that's completely fine as well. So I'm going to say the domain. I'm going to be lazy. I could say the domain of 3x squared plus 13x plus 4 over x squared plus 6x plus 8 is, but I'm going to skip that part and just do a minimal answer, is all real numbers except -4, -2. This would be completely perfect for an answer to this question, because I didn't ask for interval notation. If you just instinctively got used to interval notation and you worked this problem out ahead of me, the interval notation answer would have 3 intervals, one from -infinity to -4, another from -4 to -2, and the last from -2 to infinity, and you'd have union symbols between. So both of these answers are acceptable, especially because in my instructions I didn't specify what style of answer I was looking for. So the second kind of problem we did in section 2.1 was to reduce fractions. Again, there may have been more words in the instructions than reduce, but the key word for the ending problems in section 2.1 is the word reduce. And reduce, really, it implies to factor and cancel, and it has nothing to do with setting the denominator equal to 0. And if you take the time to set the denominator equal to 0, you're not going to get the right answer. So for the domain, I completely ignore the numerator. For the reduce problem, I can't ignore the numerator. There's some hard factoring here. I need to factor both the numerator and the denominator. And I'm going to do the numerator factoring off to the side here or down below. So I'm going to work on factoring 3x squared plus 13x plus 4. This is going to be a bottoms-up factoring because of the 3 in front of the x squared. Bottoms-up factoring, I'm going to multiply, factor, and then divide, reduce, and bottoms up. So the multiply part, I multiply the 3 and the 4 together, and I pick up an x squared plus 13x plus 4. Now I'm going to factor this, which is reasonably easy factoring. There's not a number in front of the x squared, so my firsts are going to be a couple of x's. There aren't any minuses in the problem, so my signs can only be plus. Didn't multiply this. When I said multiply 3 times 4. Should have written a 12 here because I'm multiplying the 3 and the 4, changing the 4 to that 12. My lasts after the plus sign need to multiply to 12 and add to 13. It's going to be 1 and 12 or 12 and 1. It doesn't matter which parentheses I put the 12 or the 1 in. So I'm done with the second step of my bottoms up factoring. And then my last step, I kind of do 3 things at once. I divide. I started off multiplying by 3. I'm going to divide by 3. I reduce this fraction. 12 over 3 reduces to 4. And I bottoms up the second fraction 1/3 that doesn't reduce. So that's a way to factor the numerator. I wouldn't actually factor. I don't factor using bottoms up. I factor in my head. So if you could factor this 3x squared plus 13x plus 4 without using bottoms up, you don't have to. You just need to be able to change that 3x squared plus 13x plus 4 into the factors x plus 4 and 3x plus 1. And the order that you have the factors in doesn't matter. So if you had 3x plus 1 first and x plus 4 second, it would be okay. The denominator I already factored. I factored it to x plus 2 times x plus 4. So I'm going to go ahead and rewrite the denominator as x plus 2 times x plus 4. So that's the factoring part of reducing this fraction. And now I'm going to cancel. The x plus 4s are going to cancel. And the 3x plus 1 and the x plus 2 don't cancel. They're going to be left in my answer, and I don't need the parentheses anymore. So I'm basically done. I'm ready to write my answer. And it's going to be 3x plus 1 over x plus 2 is what this fraction reduces to. And that's the end of that problem. If you factored and canceled before finding the domain, then you're going to scratch out one of the numbers that's needed for the domain. So when I did the domain, my answer had both the numbers -2 and -4 in it. If I would have reduced the fraction first and found the domain of the reduced fraction, my answer would only have the -2. That's not appropriate. You have to find the domain before you cancel. So they're completely disjoint. The domain, I only focus on the denominator. For the reducing a fraction, I focus on both the numerator and the denominator. So those are the big things that are test-worthy from section 2.1. The nice thing is, if you're good at this reducing, then you're going to do well with section 2.2. The domain kind of problems, it's just not going to come up again in the rest of the chapter. but you can't forget it because it's going to be on the test. But the reducing problems are going to really reappear today, and all the skills for reducing fractions that we did in section 2.1, they're going to carry over into section 2.2. So if you have the reducing part of 2.1 mastered, then you're going to do well today. Alright, so the beginning problems in section 2.2 are just a couple of multiplication problems. And they don't have letters, so I could do them on my calculator. But in order to be able to do the problems in this section, I need to also be able to do them by hand. But just because my calculator will do this, I'm doing this problem on my calculator. I'm doing the fraction 8/9 times 15 over 14, and my calculator tells me that my answer to problem 20, problem 2, is going to be 20 over 21. So even though that's the right answer, that's kind of not why I put this problem in the handout. I put this problem in the handout because if you can do this one by hand, then when I add letters, you can do the letters problems by hands as well. So to get to 20 over 21 without using a calculator, you usually cancel and then you multiply. And by canceling, what I'm going to do is look at each denominator and see if I can cancel a denominator with a numerator. And the first denominator, 9, will cancel with the 15 because both 9 and 15 are divisible by 3. So by hand, I'm going to divide the 9 by 3 and turn it to a 3. I'm going to divide the 15 by 3 and turn it to a 5. I'm going to move over to the 14 and see if the 14 will cancel into either the 5 or the 8 that's left in the numerator. The 14 will cancel with the 8, so I'm going to cancel it. I'm going to divide 14 divided by 2 and get 7. I'm going to divide 8 divided by 2 and get 4. So I've done the canceling, and what I have left in the numerator is a 4 and a 5. I'm going to multiply that 4 and that 5. And when I multiply the 4 and the 5, I get a 20. I'm going to leave my fraction bar, and what's left in the denominator is a 3 and a 7. I'm going to multiply that 3 and the 7 and get a 21. And that matches up perfectly with my calculator answer. So by multiplying, I kind of mean cancel then multiply. Similarly, dividing in this section is going to be canceling then divide. And for that matter, dividing is going to turn into multiplication at some point before I even do my canceling. So problem 4, division problem. Again, my calculator will smoke through this just fine. So I'm going to do it on my calculator first, so that when I do it by hand, I can know that my answer is correct. So any problem that's lacking letters, I generally can figure out how to do on this calculator. So there's the fraction 18 over 7 divided by 30 over 21. And when I hit enter, I'm supposed to know that the answer to this is 9 over 5. That would reduce to 1 4/5 or 1.8. I prefer 9 over 5 to 1 4/5, and I generally prefer fractions to decimals. So although 1 4/5 is correct, and also 1.8 is correct, this would be the best. And for me, I like improper fractions better than mixed fractions and better than decimals. So again, being able to get 9 over 5 with my calculator is nice, but it's not going to help me do the problems once they have the letters. To do the problem by hand, anytime I have a division problem, I need to change that problem to a multiplication problem at some point. To change a division problem with fractions to a multiplication problem, I change the division sign to a times sign, and I take the reciprocal of the fraction after the sign. So this is the flip, cancel, and multiply approach. When the problem's already just a multiplication with fractions, you just have to cancel and multiply. So same deal. I look at the first denominator, 7. I ask myself, can 7 cancel with 18? It can't, but 7 can cancel with 21. It cancels by dividing by 7. So I'm going to go 7 divided by 7 is 1. 21 divided by 7 is 3. I'm going to cancel the 30 with the 18, and the 30 and the 18 are divisible by 6. So I'm going to go 30 divided by 6 is 5. 18 divided by 6 is 3. If you only divided the 18 and the 30 by 3, you'll get an answer, but it won't be 9/5. It'll be something. It would be something that would reduce to 9/5, which is okay. I mean, you make yourself an extra step. If you don't divide completely and you don't simplify completely, then the fraction that you get for your answer is going to be something that's reducible. So I flipped, I canceled, and now I'm going to multiply. In the numerator, I'm going to multiply the 3 times 3 and get a 9. In the denominator, I'm going to multiply the 1 times 5 and get a 5. And again, that matched up perfectly with my calculator. So 9/5 is the perfect answer. Problem 6 is a multiplication problem, so I don't have to flip. But it's not a fraction times a fraction, which makes it hard for me to do by hand, but not so hard on my calculator. So I'll do it on my calculator first, just so I know where I'm shooting for. So 2/3 times 36. It's nice that I can make this look essentially like it does in the handout, other than my times sign instead of being a dot as an X, but that hardly matters. So the answer that I'm shooting for in this problem is the number 24. And to get there, it's easier for me to cancel if on either side of the times sign I have a fraction. And I'm going to change the 36 into a fraction by writing it over 1. Because any integer could be made into a fraction by just doing that, writing it over 1. Now I'm ready to cancel. The 3 and the 36 are reducible by 3. So I'm going to go 3 divided by 3 is 1. 36 divided by 3 is 12. The 1's not going to have a hope to reduce. So now I'm going to multiply what's left. In the numerator, what's left is a 2 and a 12. In the denominator, what's left is a 1 and a 1. So technically, I'm going to get 24 over 1 when I do the multiplication. But any fraction that has a 1 in the denominator doesn't need to be written as a fraction, and 24 over 1 is the same as 24. And again, this matches up perfectly with my calculator, so I feel good about it. The rest of the problems in this section have letters, which means I can't use my calculator because my calculator doesn't do letters. So, 8 is hopeless by my calculator, but not so hopeless by hand. In order to do a multiplication or a division problem with letters, the first thing I do is I look to see if any factoring can be done. So first, I'm going to factor, then I'm going to cancel, and then I'm going to multiply. So there's an extra step because when I was doing these things without the numbers or without the letters, I just did the cancel and multiply. I would have done a flip if there was a division problem, but it isn't. So I'm going to factor, cancel, and multiply for all the multiplication problems between 7 and 33. And when I look at this numerator, there's not a square, so it's not going to factor into 2 parentheses, but there's a common factor, so it can factor into 1 parentheses. So I'm going to factor the 5b plus 15. I'll write an equal sign because what I'm writing is equal to the line above it. If I factor out a 5 from that numerator, I'm left with a b plus 3. The 2b in the first denominator, since there isn't a plus or a minus sign between the 2 and the b, there's no chance of factoring. And similarly, the b in the right numerator has no chance of factoring. But this 3b plus 9 can factor, and it's a 1 parentheses factoring. There's not a square, so I'm not going to get 2 parentheses, but it has a common factor of a 3 that I can factor out. Now I look at the denominators and see if any denominator can cancel with the numerator. This 2b, it can cancel only with b's that don't have adding or subtracting between them. So the 2b couldn't cancel with a b plus 3, but it could cancel with a single b. Even though this has a 2, that doesn't have a 2, because both of them have b's without adding or subtracting, you can cancel the b's. So I'm going to cancel that b and cancel that b. The 2 doesn't cancel. It can't cancel with a b plus 3, but it could have canceled if that 5 was a 6 or an 8 or a 10 or any even number. I could have canceled that 2 and that 5, but they don't cancel. Similarly, this 3, it potentially could have canceled with that 5, which is a single number that's kind of in front of a parentheses. If this 5 was a 6 or 9 or 12 or a 15, this 3 and that 5 would cancel, but they don't have any. 3 and 5 don't cancel each other, so I'm just not going to do anything with the 3. But the b plus 3 will cancel. I can cancel any denominator with any numerator. You can't cancel numerator to numerator or denominator to denominator. When I look at what's left, in the numerator, the only thing I haven't canceled is a 5. I'm going to leave that 5 in my numerator and be done with the numerator. In the denominator, I see a 2 and a 3 left over, and I'm going to multiply those and get a 6. I believe the answer to this problem is 5, 6. It's not x equal to 5, 6 or b equal to 5, 6. It's just the number 5, 6. And just like in the last section, if I want to check, I can, but it's the funky checking. To check, I need to pick some number and plug it in for b in the original problem. I like picking 2. I'm going to let b equal to 2 and go in the original problem and go 5 times 2 plus 15 over 2 times 2 times 2 over 3 times 2 plus 9. In order for my answer to be correct, when I do this reduction, it has to equal 5, 6, because I say that this fraction is equal to 5, 6 once it's reduced, which means regardless of the number I plug in for b, it still needs to reduce to 5, 6. I'm going to do this all on my calculator. So fraction 5 parentheses 2 plus 15 over 2 parentheses 2. That's the first fraction. Arrow out, type my times sign, fraction 2 over 3 parentheses 2 plus 9. So that looks enough like that I'm comfortable that I entered it correctly on my calculator. If when I hit equals, it doesn't say the answer 5, 6, then I made a mistake. And, oh, beautiful, it says 5, 6. So because I get the same number by plugging in 2 into the original problem as my answer tells me, I think my answer is correct. It's not a 100% guarantee, but the chances are really good that it's correct. Just, it doesn't only have to work for the number 2. I'd have to be able to do it with 3, 4, 5, 10, any number in the world I can think of. But this is the best we can do for checking these kinds of problems, and I feel good about that answer. 10, I'm going to do the same thing. I'm going to factor and cancel, and it's only common factor factoring again. When I do 10, I'm going to expand the numerator of 14x squared to have a couple of x's. That's not really factoring, but it's going to make it easier to do the canceling. The things that will factor are the 6x minus 42 that has a common factor of a 6, and the left denominator, when I factor out a common factor of a 6, I divide the numbers by 6, I'm left with an x minus 7 in the parentheses. In the numerator, the 3x minus 21, there's not a square, so I'm not going to get a 2 parentheses factoring. There's a common factor of a 3 because both 3 and 21 are divisible by 3. When I factor out that 3, I'm left with an x minus 7. And then in the denominator, I still have that 6x. So numbers in front of parentheses can cancel with numbers in front of parentheses. This 6, it can cancel with the 14 above it, or it can cancel with the 3, but it can't cancel with an x minus 7. I'm going to start off my canceling part because what I do for these problems is I factor, cancel, and multiply. I've done the factoring part. Now I'm going to the canceling. I can cancel single numbers with single numbers. I consider the 6, the 14, the 3, and the 6 single numbers because there isn't a plus sign connecting these 14 and the 6 to the letter. So I can consider those single numbers that can cancel with each other. So I'm going to cancel the 6 and the 3. 3 divided by 3 is 1. 6 divided by 3 is 2. I could cancel the 2 with the 14, or I could cancel the 6 with the 14. I'm going to cancel the 6 with the 14 because that's likely what most people would do. And to do that, I go 6 divided by 2 is 3. 14 divided by 2 is 7. I can cancel the x minus 7s because there's one up top and one down low. You can cancel between fractions or within the same fraction. And lastly, I have single x's in the numerator because the x's in the numerator aren't attached to anything with a plus or a minus sign. They'll cancel with another x that isn't attached with a plus or a minus sign. So from my x squared, my x's cancel. And I'm left with a 7, an x, and a 1 in the numerator. So what I have left in the numerator is a 7, an x, and a 1. And in the denominator, what I have left is a 2 and a 3. So I've factored, I've canceled, and now I'm going to multiply. 7x times 1 is going to be 7x. 2 times 3 is going to be 6. So I claim this is my answer. And the nice thing is I can always check. So I'm going to check by I like using 2. I'm going to let x equal 2 and go to the original problem and go 14 times 2 squared over 6 times 2 minus 42 times 3 times 2 minus 21 over 6 times 2. So that's putting 2 into the original problem. I also have to plug 2 into my answer because my answer has an x. So I'm going to go 7 times 2 over 6. My answer is correct. Both of these are going to reduce to the same number. So I'll start off with this one, which is a little bit harder. Fraction 14 parentheses 2 squared over 6 parentheses 2 minus 42, arrow out, times sign, fraction 3 parentheses 2 minus 21 over 6 parentheses 2, and this, if I did it properly on my calculator, reduces to 7/3. For my answer to be a correct answer, when I do the computation 7 times 2 over 6, I best also get 7/3. This was a lot easier, so I'm going to go 7 parentheses 2 over 6, and I get 7/3 again. So my best guess is that my answer is correct because when I took a number and plugged it into the unreduced problem, I got the same result as plugging the number into the reduced problem. All right, I'll keep going. 12 is a tricky problem that likely wouldn't make it onto the test because it has factoring out a negative. And I rarely put a problem where you have to factor out a negative on the test, but I'll go ahead and do it. So the problem with number 12 is this numerator, it's written with the x second. What I'm going to need to do is I'm going to rewrite this with the x first and the 2 second, and I'm going to factor out a negative 1. So I'm not going to work with the 16, single number, it can't factor. The x minus 2 in this denominator, it doesn't have a square, so it's not going to factor into 2 parentheses. It doesn't have a common factor, so it's just actually not going to factor at all. this numerator, I'm going to rewrite it as negative x plus 2, and then I'm going to factor out a negative 1. So negative x plus 2, it has the nice order, but it has a negative in front of the x, so I'm going to factor out a negative 1. When I factor out a negative 1, the negative x turns to a positive x, the positive 2 turns to a negative 2. So that's the work that just needs to be done in order to be able to cancel the terms that have the minus. The 8, that's a single 8, it's just going to stay a single 8. Now I'm ready to cancel then multiply. So this x minus 2 will cancel with that x minus 2. I'm going to cancel and cancel. Technically, these turn to 1s when I cancel them, but usually I don't take the time to write that. I'm also going to cancel the 8 and the 16. 16 divided by 8 is 2. 8 divided by 8 is 1. What's left in the numerator is 2 times negative 1 times 1. That's this 2, this negative 1, and that 1. And in the denominator, I have 1 times 1. If I multiply out the numerator, positive times a negative is a negative. It multiplies out to be negative 2. The denominator multiplies out to be 1. So for my answer, I could write negative 2 over 1, but I don't need to write the answer as a fraction because the denominator is just a 1. I'm going to go ahead and check. I can't plug in 2 for x for my checking, because if I plug in 2 for x, I'll get a 0 in the denominator and it's undefined. When I'm checking, I have to pick a number other than 0 and 1, because sometimes they work when they shouldn't, but that I don't get undefined. So I'm going to plug in x equal to 3. Because my answer doesn't have an x in it, when I plug 3 in for x into the original problem, I better get exactly that number. So I took these x's and I plugged in 3. If I plugged in 2, I would have got 16 over 0, which is undefined, and that's not going to help me do my checking. So I'm going to do this. Because my answer doesn't have an x in it, there's no number I can plug into my answer, which means this better come out to be negative 2. So I'm going to go 16 over 3 minus 2 times 2 minus 3 over 8. And when I hit equals, if I come up with a negative 2, I'll believe my work and I'll be done. Beautiful. Because this comes out to negative 2, which is the same as my answer, I feel good about it. So that's very unlikely to be on the test, just because factoring out negative 1s isn't something that comes up a lot, and on a test it'd be real easy to miss out. So that would likely not be something that comes on the test. Similarly, I would be shocked if something like 14 would make it onto the test that has factoring with 2 letters as opposed to 1. It couldn't hurt to watch this, couldn't hurt to try to do this without me, but in a Math 122 class or an intermediate algebra class, that wouldn't be something I'd put on a test. In a college algebra class, I might do that. So factoring is hard. So the 2 things that need to be factored are this numerator, and if I look at this numerator, this x squared minus xy, it actually has a common factor of an x. When I think of this numerator, I can think of it as xx minus xy, and because on either side of the minus sign in the numerator there's an x, I can factor out an x. So when I go to do my factoring part of this before my canceling, this numerator is actually a 1 parentheses factoring. I'm going to write an x and then a single parentheses. When I factor out an x, I take one of the 2 x's away from the x squared, I take the x away from the xy, and inside the parentheses I'm going to have an x minus y left over. Single y had no hopes of factoring. This x squared minus y squared, that's a classic square with a minus or difference of squares. It's going to factor into 2 identical parentheses, one with a plus, one with a minus. This isn't that different than like factoring x squared minus 9 or factoring x squared minus 25. Factoring, x squared minus 9 most of you probably could quickly know that that's x plus 3 and x minus 3. And this is the same style of problem. The reason x squared minus 9, which is really x squared minus 3 squared, and this are similar is because they're both the subtraction of two squares. You don't think of x squared minus 9 as x squared minus 3 squared, but the similarities between this problem, which isn't from this particular problem, and this they're the same problem, just one's slightly more complicated. So this one's a difference of squares, and differences of squares factor into two identical parentheses. One has a plus sign, one has a minus sign. And you divide the exponents by 2. And the single x doesn't cancel or factor. So now I'm ready to cancel. X plus y can only cancel with another x plus y, and x plus y can't cancel with a single y. This x plus y has nothing to cancel with, but this x minus y's will cancel. And also, single x outside of parentheses will cancel with a single x, and those will cancel. If I look at what's left in the numerator, the only thing I haven't canceled is a y. The only thing I haven't canceled in the denominator is an x plus y. You can't cancel an x plus y with a single y. You can only cancel an x plus y with an x plus y. I claim that's the answer. I'm going to check. I'm going to let x equal to 2 and y equal to 3. I don't want to make them the same numbers. I don't like using 0 and 1. So I'm going to go to the original problem and go 3 for y, 2 for x, 3 for y, 2 for x. This time I'm using time signs as opposed to parentheses. So that's plugging in 2 and 3 for x and y into my original problem. Also, I'm going to do it into my answer. Plug in 3 for y, 2 for x, and 3 for y. I'm going to do both of these on my calculator. That's silly to do on my calculator. But for my answer to be hopefully correct, these things have to reduce to the same number. So I'm going to go 3 over 2 squared minus 3 squared times fraction 2 squared minus 2 times 3, of which I could use a parentheses instead of a time sign, over 2. So that's doing the original problem, plugging in 2 for x and 3 for y. I get 3 over 5 when I do that. I better get 3 over 5 for the next fraction, otherwise I've made a mistake. So I'm going to this fraction, fraction 3 over 2 plus 3, and my calculator tells me that that's also 3 over 5. So because when I picked random numbers I got the same results by plugging them into the original problem as to my answer, I believe my answer is correct. Again, so the last two problems, 12 and 14, are just not things I'd likely put on a test. 16 would be considered a friendly test question in that it has easy factoring. So for this problem, it's the first division problem, and I need to deal with that division. So I'm going to flip, factor, cancel, and multiply. So division problems, before I cancel, I need to flip and make them a multiplication problem. So at some point, you need to transform the problem into a multiplication problem, and you do that by flipping the fraction to the right of the division sign. Nicely, all the factoring is just common factorings. There aren't any squares, so I'm not going to get two parentheses factorings. I'm just going to factor out numbers. In the left numerator, I'm going to factor out a 2, be left with an x plus 5. In the left denominator, I'm going to factor out a 5 and be left with x minus 2. In the right numerator, the 3x minus 12, I'm going to factor out a 3 and be left with x minus 4. And in the right denominator, the 3x plus 15, I'm going to factor out a 3 and be left with an x plus 5. So single numbers in parentheses will cancel with single numbers in front of parentheses, should I say, whether they're in the same fraction or opposite fractions. So I look at this 5, and the two numbers in front of the parentheses, the 2 and the 3, 5 doesn't cancel into either of those, so I can't do anything with the 5. An x minus 2 can only cancel with an x minus 2. It can't cancel with an x minus 4, so I can't do anything with it. A single 3 in front of a parentheses will cancel with a number in front of a parentheses. I'm going to go ahead and cancel these. Even though they're in the same fraction, it's okay. You can cancel between fractions or within the same fraction as long as you're doing a numerator to a denominator. And then x plus 5 will cancel with an x plus 5 as well. Then all the canceling I can do, what I have left in the numerator is a 2 and an x minus 4. And in the denominator I have a 5 and an x minus 2. X minus 2's can only cancel with x minus 2, so I can't cancel it with the x minus 4. It's okay to not multiply this, but you certainly can multiply it out as well. Usually, if something's factored, we usually don't destroy the factoring. But both of these answers would be acceptable. Both of them can be checked. So let me do an easy checking. I can't plug in 2. If I plugged in 2 for x, I'd get a 0 in that denominator, which would be undefined. So I'm going to just let x equal to 3, and I'll plug it into my original problem. I'm going to go 2 times 3 plus 10 over 5 times 3 minus 20 divided by, then go over here, 3 times 3 plus 15 over 3 times 3 minus 12. And then I'll do it to my answer. In either version of the answer, it doesn't matter. I'll do this one. I'm going to go 2 times 3 minus 8 over 5 times 3 minus 10. And these better come out to the same number, otherwise I've messed up. So do this one first because it's harder. Fraction 2 parentheses 3 plus 10 over 5 parentheses 3 minus 20 divided by, not multiply, fraction 3 times 3 plus 15 over 3 times 3 minus 12. And you could tell if you picked a bad number to check if you get a math error, because that's how it shows undefined. So you can't see everything I've typed in, but I think I've typed it incorrect. And I get 2/5. Better be the case that I get 2/5 when I do that same trick, plugging 3 into my answer. So I'm going to check my answer now. Plugged 3 in. I'm going to go 2 times 3 minus 8 over 5 times 3 minus 10. And I get negative 2/5. That's disheartening because that's not the same. Now I'm not sure if I missed the negative sign or if I messed up. So let me redo this on my calculator before I start looking for errors. So fraction 2 parentheses 3 plus 10 over 5 parentheses 3 minus 20 divided by, so that part looks good, divided by fraction 3 parentheses 3 plus 15 over 3 parentheses 3 minus 12. I really want to see a negative 2/5. I see a positive 2/5. This is troubling me. Let me do the answer again to make sure that that wasn't where I messed up. So fraction 2 parentheses 3 minus 8 over 5 parentheses 3 minus 10. So they're not coming out the same. So this tells me I think I made a mistake somewheres. And I see my mistake now. So you might have saw my mistake when I was doing the problem, but I didn't. And that's the nice thing about checking. So I checked, I got a conflict here, I double checked, still got that conflict, so I've made a mistake. And that's how you're going to find out when you're doing your homework or you're doing your test if you've made a mistake. If you can't get these two numbers to come out to be the same, then you've screwed up somewheres. And I can see where I screwed up, and hopefully you saw that as I was doing it. this 5x minus 20, when I wrote it here, I don't know why, I changed it to 5x minus 10. That was completely wrong. So I should have written 5x minus 20 there. I'm going to redo this whole problem, and that might drive you bonkers, but it's going to be kind of hard to follow. So I'm going to flip to a different sheet of paper and relive this problem just because I made a mistake, and I want to fix that mistake. So the original problem had a 5x minus 20, and I'm going to not write down the original problem. I'm going to write the flipped version of the original problem. So that's the original problem fixed with my 20 in the right place. Now I'm going to factor. That still factors by a common factor of a 2. When I factor out a 2, I'm left with an x plus 5. When I factor out a 5, I'm left with an x minus 4. When I factor out a 3, I'm left with an x minus 4. When I factor out a 3, I'm left with an x plus 5. So this is going to be a much simpler answer. Now I'm going to cancel. This 5 still had nothing to cancel in the numerator. Now I have something that does cancel that I couldn't cancel before. I'm going to cancel the x minus 4s with each other. I'm still going to cancel these 3s, and I'm also going to cancel these x plus 5s. So I claim that the answer to this is just the fraction 2 over 5. And that when I plug a number into the original problem, when I plug a number into this problem, it should reduce to 2/5. So I'm going to redo this. I'm going to go to the original problem and just do what I did, but I'll do it with a different number. I will let x equal to, the heck, I'm just going to do 3. So the original problem was this problem. I'm going to change the x to 3. I've already done this, but I'll do it again. I'll go 2 times 3 plus 10 over 5 times 3 minus 20 divided by 3 times 3 plus 15 over 3 times 3 minus 12. That I've done on my calculator a couple times, and I know that I get 2/5, which is a beautiful thing because that's what I said my answer is. So that's my save. It's probably not a bad thing that I make a mistake every now and then, so that you can see what you need to do when you make a mistake. More often than not, when I make a mistake, I just do the problem completely over because I have such a hard time finding my mistake that I'll not see it often. So usually I just pull out a new sheet of paper and start the problem over, and hopefully I don't make the same mistake twice. All right. 18 is another division problem, which means I need to flip. And you're flipping the fraction to the right of the division sign. So anytime we have a division problem, at some point before we cancel, that division sign needs to be turned into a multiplication sign, and you do that by flipping the fraction to the right of the multiplication sign. Now I'm going to factor. The 5y doesn't have any factoring, doesn't have any pluses in it, so there's no hope for factoring. The 4y minus 12, there's a common factor of a 4. I'm going to factor out that 4 and be left with a y minus 3. The 6y minus 18 has a common factor of a 6. It's a 1 parentheses factoring. I'll write a 6 outside of parentheses and be left with a y minus 3. The 10y squared doesn't factor because there isn't any pluses or minus signs, but I like expanding the exponents. So I have I should probably write equal signs. If you do or don't write them, I don't care so much. But this just says this equals to the line above it, which equals to the line above it. It's kind of mathematically nice to look at with the equal signs. But you'll notice that more often than not, I get lazy and I don't write the equal sign. Well, sometimes I do, and sometimes I don't. I'm being inconsistent, and it's okay. These are probably visually appealing to somebody that reads mathematics. That just tells me, yes, this is equal to the line above it. It's not some new problem that I made up, but it's not that important. So single numbers in front of parentheses when I go to cancel will cancel with single numbers in front of parentheses. So this 4 and this 6 will cancel. 4 divided by 2 is 2. 6 divided by 2 is 3. Y minus 3's will cancel. Single numbers next to y's will cancel with single numbers next to y's. Single numbers meaning there's no plus or minus sign between them. So I'm going to cancel that 10 and that 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Single y will cancel with a single y that's not part of an adding or subtracting. So cancel and cancel. What's left in the numerator that I haven't canceled is a 1 and a 3. In the denominator, there's a 2, and a y. So what's left after I do my canceling are those items. Now I'm ready to write my answer. In the numerator, I'm going to multiply 1 times 3 and get a 3. In the denominator, I'm going to multiply 2 times 2y and get 4y. Again, I can check. And I can't plug 3 in, because if I plugged 3 in, I'd get a 0 in the denominator. I'm going to let y equal to 2 for my checking. In the original problem, I'm going to go 5 times 2, which I could use a times sign or a parentheses, over 4 times 2 minus 12 divided by 10 times 2 squared over 6 times 2 minus 18. And then I'll do the same for my answer. For my answer, I'll go 3 over 4 times 2. So we'll do both of these on my calculator. Hopefully they come out to the same number. So first one, fraction 5 times 2, could use a parentheses instead of a times sign, over 4 times 2 minus 12, error out, divided by fraction 10 times 2 squared over 6 times 2 minus 18. So I have something that looks, well, I don't know about how that squared looks there. I'm going to clean this square. I don't think that that's going to mess me up. Get up here, get me over somehow. So I look at this x squared that I wrote. I don't like it so much. I'm going to delete this and hit the x squared key again. Oh, that messes me up even more. I'm going to delete this, and it's supposed to be, oh, it's just 5 times 2. There's no squared there, so that's my issue. So 5 times 2. Oh, that's maybe I did have it written right, maybe I didn't. But now I feel better about how it's written. The parentheses might even be nicer to use than the times sign. I could add 5 parentheses 2, 4 parentheses 2 instead of the times. But times and parentheses, for our purposes here, the parentheses are just replacing a times sign. But let me hit enter, and hopefully I'm feeling good about this. So I get 3/8. I can tell this one's going to be 3/8, but I'll do it on my calculator just so I'm certain. So 3 over 4 times 2, that's also 3/8. So I feel good about my answer because I've done the checking that I can do. 20, the factoring starts to get harder. There's no flipping because it's not a division problem. I have 3 factorings to do. The first thing I'm going to do is factor this x squared minus 9. I don't need any side work to factor that. That's a square with a minus. I'm going to get 2 identical parentheses, one with a plus, one with a minus. Take the square root of the 9. That x squared minus 9 factors into x plus 3 and x minus 3. So if as we get into the factoring, harder factoring part of this section, you find the factoring slowing you down, that means you probably need to review factoring. Either come visit me in my office and I can help you relearn factoring, and or look at my videos in chapter 1. The 3x plus 4, because it doesn't have an exponent, you're not going to get 2 parentheses in your factoring, and there's not a common factor, so it's just hopeless. It just stays 3x plus 4. The 9x squared minus 16, it's going to factor a lot like the x squared minus 9, because each one of these pieces is a square. 9x squared is a square because it's 3x times 3x. 16 is a square because it's 4 times 4. To be a square, it means I can write something as 2 identical terms or factors being multiplied. So 9x squared minus 16 is going to factor just like x squared minus 9, in that I'm going to get two identical parentheses, one with a plus sign, one with a minus sign. And in each parentheses I write what makes each a square. The x squared plus 6x plus 9 is going to factor into two parentheses. Nicely, there's no minus signs, so I don't have to worry about signs. There's no number in front of the x squared, so I don't have to worry about bottoms up. When I factor this one, my lasts have to multiply to 9 and add to 6, because I need to get that 9 and the 6, and it's just going to be a 3 and a 3. So I've done my factoring. Now I'm going to go to cancel. This 3x plus 4 and that 3x plus 4 will cancel. This x plus 3 and that x plus 3 will cancel. The x plus 3 can't cancel with an x minus 3 because they're not exact, and also the x plus 3 can't cancel with an x minus 4. When I go to write my answer, I'm not going to FOIL out the numerator, but you can. Usually, if the numerator comes out factored in these problems, you just kind of leave it. If you took the time to FOIL the numerator, and you did first our x times 3x, which is 3x squared, outers are x times minus 4, which is minus 4x, inners are minus 3 times 3x, which is minus 9x, last are minus 3 times minus 12, which is plus 12, and you rewrote the numerator as 3x squared. These terms are both negative. I'm add them and keep them negative and get minus 13x and leave the plus 12. If you wrote that as an answer, it's completely fine. Generally, if you have something that's nicely factored, I don't usually unfactor it. So I'm done. Both of these are acceptable answers. I'm going to use this answer for my checking. I'm going to plug in 2 for x. And hopefully I haven't made a mistake. So I'm going to go 2 squared minus 9 over 3 times 2 plus 4 times 9 times 2 squared minus 16 over 2 squared plus 6 times 2 plus 9. So I'm going to plug 2 into the original problem, and I'm going to plug 2 into my answer. For my answer, I'm going to go 2 minus 3 and 3 times 2 minus 4 over 2 plus 3. I did mostly parentheses for my multiplying, and I didn't put a parentheses here, but I could have. So I'm going to do these two computations. Harder computation first. Fraction, parentheses that I don't really need. 2 squared minus 9 over 3 parentheses 2 plus 4 times fraction 9 parentheses 2 squared minus 16 over 2 squared plus 6 times 2 plus 9. Entered that kind of fast, but hopefully you could enter that equivalently fast. And when I did this, I get negative 2/5. Isn't that odd? Hopefully I get negative 2/5 when I do the 2 into my answer. So for my answer, fraction 2 minus 3 times 3 times 2 minus 4 over 2 plus 3. Oh, beautiful. So for both my original problem and my answer, when I plugged in 2, I get minus 2/5, so I feel good about my work. That big X means times in this problem. So I have 4 factorings to do. Let me just kind of do these factorings in line. So I'm going to factor first x squared minus 9x plus 20. I know that my first need to be a couple of x's, that my signs are going to be minus and minus, so I can get like a minus 1 and a minus 20, a minus 2 and a minus 10, or minus 4 and a minus 5. Those are my choices for my lasts, because I know the signs have to be minus and minus. I know I have to multiply to 20, and those are minus and minus, and they multiply to 20. But they also need to give me a 9, and this 4 and this 5 are the ones that give me the 9. So the first factoring that I'm going to do is this numerator. And I'm going to write that as x minus 4 times x minus 5. Next thing I'm going to factor is x squared minus 5x plus 6. Again, I don't need bottoms up because there aren't any numbers. There isn't a number in front of the x squared. My signs are minus and minus, which means I could have a minus 1 and a minus 6, or a minus 2 and a minus 3. They both look like they give me a 5, but the 6 and the 1 actually, because they have the same signs, they actually would give me a 7. Minus 1 and minus 6 add up to be negative 7. Minus 2 and minus 3 are the pair that I need here because they give me the 5 that I need. So in the denominator of my work, I need an x minus 2 and an x minus 3. Next thing I'm going to factor is x squared minus 3x plus 2. Again, the signs are minus and minus. My first have to be a couple of x's. And really the only choice that I have for my lasts are 1 and 2 because those are the only numbers that multiply to 2. Fortunately, minus 1 and minus 2 add up to 3. So after the x's, I'm going to get a minus 1 and a minus 2. And lastly, when I go to factor the x squared minus 5x plus 4, I know my first have to be a couple of x's. My lasts are either going to be minus 1 and minus 4 or minus 2 and minus 2 because I need a couple of minuses and the signs, numbers have to multiply to 4. The minus 2 and minus 2 aren't going to give me that 5, but the minus 1 and minus 4 will give me the 5. So I'm going to get a minus 1 and a minus 4. So I have all 4 factorings done, maybe quicker than you wanted me to do them, but I know this video is getting to be a little bit long, so I wanted to speed up a little bit. Now we can cancel any denominator to any numerator, as long as we have the same factor. So this x minus 2 and that x minus 2, top and bottom, those will cancel. This x minus 1 and that x minus 1, even though they're not in opposite fractions, I still can cancel them. And this x minus 4 and that x minus 4 will also cancel. The only things that haven't canceled are an x minus 5 and an x minus 3. I don't even need the parentheses anymore. I'm going to check. I'm going to plug in. I can't plug in. If I plug in 2, 3, 4, 1, 2, 3, 4, or 5, it's going to make a parentheses 0, and that's probably not the best. I'm going to plug in 6. I'm going to plug in 6 for here and go 6 minus 5 over 6 minus 3. The reason I'm not plugging in 1, 2, 3, 4, or 5 is because 1 would make that parentheses 0, 2 would make that parentheses 0, 3 would make that parentheses 0, 4 would make that parentheses 0, 5 would make that parentheses 0. Putting in numbers that make a parentheses of a factor 0 probably isn't such a great idea. It might make things look like they work when they don't. I'm going to plug in 6 into these without even writing down what I'm doing. So I'm going to go fraction 6 squared minus 9 times 6 plus 20 over 6 squared minus 5 times 6 plus 6. Arrow out, times sign, fraction, now 6 is into these. 6 squared minus 3 times 6 plus 2 over 6 squared minus 5 times 6 plus 4. So for all of those x's, I plugged 6 in, and this reduces to 1/3. I'll do the same thing for my answer. I'm going to go, for my answer, plug in 6 for the x's, 6 minus 5 over 6 minus 3, and when I hit equals, I get 1/3 again. So I feel really nice about this answer because when I took a number, plugged it into the original problem, and my answer, I got the same result. 24, I need to flip, factor, and cancel. Flip because it's division, so I'll do that flipping first. I'm going to make this x squared plus 6x plus 5 over x squared plus 4x plus 3 times x squared minus 9 over x squared minus 25. Flip, now factor. First thing I'm going to factor is x squared plus 6x plus 5. Easy enough that I don't even need to do that off to the side. When I go to factor this, my firsts are a couple of x's. There's no minuses, so I don't have to worry about minus signs. My last need to multiply to 5 and add to 6, and 1 and 5 or 5 and 1 will do that. The x squared plus 4x plus 3, two parentheses, no bottoms up because there's not a number in front of the x squared. Signs nothing but pluses. Last, multiply to 3 and add to 4. 1 and 3 will do that perfectly. To the right of the times sign, x squared minus 9 is a square with a minus, or a difference of squares, so you get two identical parentheses, one with a plus sign, one with a minus sign. The x squared minus 25 factors just like the x squared minus 9 in that you get two identical parentheses, one with a plus sign, one with a minus sign. Have all four pieces factored. Now I'm going to cancel. As long as I go top to bottom, it doesn't matter if I'm in the same fraction or opposite fractions. The x plus 1s will cancel. The x plus 3s will cancel. The x plus 5s will cancel. What I'm left with is an x minus 3 over x minus 5. I can plug 2 in, so I'm going to check by plugging 2 in. So I'm going to go 2 squared plus 6 times 2 plus 5 over 2 squared plus 4 times 2 plus 3 divided by 2 squared minus 25 over 2 squared minus 9. Plug in 2 to the original problem for the x's, and I'll plug in 2 to my answer. If I get a duplication, I feel good about my work. If I don't, then I probably redo my calculator work first. So first plugging in 2 for these x's. So fraction 2 squared plus 6 times 2 plus 5 over 2 squared plus 4 times 2 plus 3 divided by fraction 2 squared minus 25 over 2 squared minus 9 equals, I get 1/3. Go to my answer and do the same thing. Plug in 2 and 2 and get fraction 2 minus 3 over 2 minus 5. And I also get 1/3. So I feel good about my work because I got the same result when plugging 2 into the original problem as I did to my answer. 2 was a safe number to pick because it didn't make any of the parentheses 0. Getting close to the end of this, the factoring is going to progressively get harder. The problems will get a little bit trickier. 26, it's a multiplication problem, so I don't need to flip. But I like both pieces to be fractions when I have a multiplication problem. And the first piece wasn't a fraction, but it certainly is not that hard to make it a fraction. So I took the time to make this as a fraction times a fraction by writing the y minus 4 as a fraction by writing it over 1. The y minus 4 doesn't have a common factor. It doesn't have an exponent. I really don't even need these parentheses, but they're there. I left them there. The only thing that can factor is this y squared plus 2y minus 24. And it's moderately easy factoring. To factor this, no bottoms up because there's not a number in front of the y squared. I know my first are a couple of y's. My last have to have opposite signs, one plus and one minus. So it can be plus 1 and minus 24, or plus 24 and minus 1, or plus 2 and minus 12, or plus 12 and minus 2, or plus 6 and minus 4. That's the pair I'm going to need because 6 minus 4 gives me that positive 2. I knew the signs had to be opposite because the minus in front of the 24. So I'm going to do a plus 6 and a minus 4. I've got it factored. Now I'm going to cancel. I'm going to cancel the y minus 4s. That's the only thing that's going to cancel because a y plus 6 can't cancel with a y without a plus 6. What's left in the numerator is just this single y. What's left in the denominator is really just that y plus 6. I think that's my answer. I'm going to plug 2 into the original problem and 2 into my answer. Plugging 2 into the original problem, I'm going to go 2 minus 4 times 2 over 2 squared plus 2 times 2 minus 24. And then plugging 2 into my answer, I'm going to go 2 over 2 plus 6. Better get the same number for each of these computations. Easy enough to check, so that's why I'm doing the checking. So 2 minus 4 times fraction 2 over 2 squared plus 2 times 2 minus 24. That's plugging this version in. I get 1/4 when I do that. And over here, 2 over 2 plus 6, I also get 1/4. So I feel good about my work again. So the answer to this problem is the fraction. The answer to this problem is y over y plus 6 without the cross through the plus 6. So y over y plus 6. All right. 28's a division problem, so I need to flip it. I like both pieces to be fractions, so I'm going to do a couple things up front. I'm going to make the 4x squared minus 9 as a fraction. I really don't need the parentheses around it, but I'm going to leave them. And I'm going to change the problem to a multiplication problem. Anytime I have a division problem with fractions, before I cancel, I need to make the problem a multiplication. So I did two things. I made both pieces fractions because it makes it easier for me to see the canceling, and I changed the division to a times by flipping the fraction to the right of the division sign. Now I'm going to factor. There's a square there, and it's supposed to be an easy factoring. This is a double parentheses that are basically the same factoring because this is a square or a difference of squares, because each piece can be written as something times itself. My factorings are going to have two essentially identical parentheses, one with a plus, one with a minus. X plus 3 doesn't have a square, so it's not a two parentheses factoring. Doesn't have a common factor, so there's no factoring I can do. 4x plus 6 doesn't have a square, so it's not two parentheses factoring. Does have a common factor of a 2, so I can factor out that 2. So the denominator 4x plus 6 factors into 2 times 2x plus 3. I can cancel the 2x plus 3's. That's the only thing I can cancel. What's going to be left in the numerator is something that you can FOIL out if you want to, but you don't have to FOIL out numerators. What's left in the denominator is just a 1 and a 2, which multiplies to be 2. If you took the time to FOIL out the numerator, your numerator would look different than mine, but it would be okay. I'm going to check by doing 2 again. So I'm going to check. I'm going to plug in 2 here. I'm going to go 4 times 2 squared minus 9 divided by 4 times 2 plus 6 over 2 plus 3. And I'll plug a 2 in here and go 2 times 2 minus 3 times 2 plus 3 over 2. Do both of those, hopefully they come out to the same number. So first one, parentheses 4, and then parentheses 2 squared minus 9. Close out my parentheses. Divided by fraction 4 times 2 plus 6 over 2 plus 3. So assuming I haven't messed up, I get 5/2 for plugging 2 into the original problem. Now I'm going to plug 2 into my answer. I'm going to go fraction, parentheses, 2 times 2 plus 3, should be minus 3. And then 2 plus 3 over 2. Better say 5/2. Does, so I feel good about this. If it hadn't said 5/2, then I'd have to start hunting around to figure out if I made a mistake on my calculator or if I made a mistake in my algebra. So the answer is perfectly this. And again, if you wrote for your answer 2x squared plus 3x minus 9 over 2, because you took the time to FOIL that out, and that's what you'd get if you FOILed and simplified. That would be okay as well. But you don't have to FOIL out numerators that are factored. 30. This is a little bit harder. I like having fractions on either side of my sign. So for this problem, it's not a fraction divided by a fraction, and that might mess me up. So I can write the x squared minus 10x plus 25 as a fraction by writing it over 1. When I'm dealing with a division problem, I need to change the division problem to a multiplication problem. And I make a division problem a multiplication problem by flipping the fraction to the right of the division sign. So I'm going to take that division sign, make it a time sign, and flip this fraction. I really don't need this parentheses, but it's okay to have it as well. So now I've taken the problem, I've made it into a multiplication problem, now I'm ready to factor. X squared minus 25 is easy factoring because it's a difference of squares. I get two identical parentheses, except one has a plus sign and one has a minus sign. That's a simple x plus 5x minus 5. The 2x plus 10, there's a common factor of a 2 that I'm going to factor out and be left with an x plus 5. The single 1 can't factor, but this x squared minus 10x minus 25, my first are a couple of x's, my signs are minus and minus. So after these parentheses, I could either put a minus 1 and a minus 25, or a minus 5 and a minus 5. Because I need to get the minus 10, the minus 5 and minus 5 will give me that, because those add up to minus 10. So I have the x plus 5x minus 5 factoring, the 2 times x plus 5, and the x minus 5x minus 5. Now I'm going to cancel. X plus 5s cancel, x minus 5s cancel. In the numerator, I have just a 1 left. In the denominator, I have a 2 and an x minus 5 left. It would be okay to not multiply out that denominator, but both of these would be okay for answers. I think I can plug 2 in, so I'm going to plug 2 in. Over here, I'm going to go 2 squared minus 25 over 2 times 2 plus 10 divided by 2 squared minus 10 times 2 plus 25. And down here, I'm going to do this version. I'll do 1 over 2 times 2 minus 10. Hopefully, when I plug 2 into the original problem and I will plug 2 into my answer, I get the same number, so I know my answer is correct. This one's harder. I'll do it first. Fraction 2 squared minus 25 over 2 times 2 plus 10 divided by parentheses 2 squared minus 10 times 2 plus 25. So I've entered this the best I can. That's, you can see it all. And when I hit enter, I get negative 1/6. Better be the case when I do this down there that I also get negative 1/6. So I do the fraction 1 over 2 times 2 minus 10. I also get negative 1/6 because I got the same number when I plug 2 into the original problem as into my answer. I feel good about my answer. And again, if you want to multiply out parentheses, you can, but it's not necessary. I just have one more problem left. Yeah, last problem. Same deal that I did for the last problem. I'm going to make this into two fractions. So I'm going to make this x squared minus 3x over 6x divided by 2x squared minus 5x minus 3 over 1. I like everything to be fractions when I'm dealing with multiplying and dividing by fractions. Now I'm going to flip. I'm going to I don't know, this should be 3x here. I don't know why I wrote 36. But that should be x squared minus 3x. I'm going to flip, and I'm also going to write this with 2 x's. So I'm going to write xx minus 3x over 6x times 1 over, and I really don't need this parentheses, but it's okay to have it. Easy factoring here. I'm factoring out an x. When I factor an x out, there are 2 x's there, I'm left with 1. After the minus sign, there's only 1 x, I'm left with a 3. Here's the hard part. I need bottoms up factoring for this. I'm going to just try to squeeze this factoring in right here. So to factor 2x squared minus 5x minus 3, I multiply, get x squared minus 5x minus 6. I factor that into x plus 1, x minus 6. I divide, reduce, and bottoms up. I started off multiplying by 2. I'll divide by 2. The x plus 1/2 doesn't reduce. I bottoms up to 2x plus 1. The 6 over 2 reduces to 3, and I get an x minus 3. So the denominator, 2x squared minus 5x minus 3, needed to be factored. Because it took bottoms up factoring, I did it off to the side. I multiplied, factored, divided, reduced, and bottoms up, and got this denominator to factor into 2x plus 1 times x minus 3. Now I'm ready to cancel. Single x's in front of parentheses can cancel with single x's multiplied by numbers, even in the same fraction. So I'm going to cancel those x's. I'm also going to cancel the x minus 3's. What I have left in the numerator is nothing but a 1. I can't write an answer of a fraction without a numerator, so I need to leave that 1 behind. And in the denominator, I have a 6 and a 2x plus 1 left over that you don't have to, but you can multiply out. So both of these would be okay answers. And I'm going to be completely lazy and not check this one just because I'm kind of worn out from this. But you can certainly take the number 2, plug it into the original problem, plug it into the answer, and assuming I haven't made a mistake, then it should work perfectly. And if I had made a mistake, then you can tell me that I made a mistake if you checked it, but I don't think I have. All right, so that's all the even problems in section 2.2. Hopefully you see the big connection between section 2.1 and 2.2, and that you're feeling comfortable with that stuff. When I lecture, we're skipping section 2.3. It's probably going to be completely deleted, so you won't even see it. Either there will be no 2.3, and we'll do 2.4 next. And you should get really good at sections 2.1 and 2.2 before we jump into section 2.4, just because it's a little bit different. So far we've reduced fractions, found domain, multiplied and divide fractions. Section 2.4 is adding and subtracting fractions, and adding and subtraction is just a little bit harder because you have to get common denominators, which I didn't need in any of today's sections. All right, that's got to be enough.